Hello. Today's video I'm going to be looking at binary numbers. And I'm going to start from the basics, and I'm going to have a series of videos all about binary numbers and different ways of using binary to represent different values. If you haven't done much computer programming or very much math, then you may only understand binary code as the ones and zeros on an old school green screen you see in movies and TV shows when the director or whoever wants to tell people, oh, this is cool hacker shit. But the question remains, what is those ones and zeros? What is that hacker stuff? I'm going to see if I can try to answer that. At its very core, binary is a number system. What is a number system, you ask me? A number system is basically a way of counting. Binary is very similar to the number system that we use in our everyday life, which is decimal. Decimal is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, the things that we deal with every day of our lives. And if you don't know what those are, then I suggest returning to your kindergarten class. So when you're counting in decimal, you count 1, 2, 3, 4, 5, 6, 7, 8, 9. Binary numbers are pretty much the same as decimal numbers, except instead of having from 0 to 9 to work with to use to count things, you only have 0 and 1. And if we look at decimal again as the example, when you get to 9, you run out of ways to continue to count up using only one character. So you have to go to 10, which is 2 characters. Binary is the same way. When you're counting in binary, you go from 0, which is 0, you go to 1, which is 1, and then you have no more characters with which to count up, so you have to go to 10, which is 2. After that, you go to 1, 1, which is 3. And then again, you run out of places, and you go to 1, 0, 0, which is 4. So these are the first 8 binary numbers, not including 0. So we got 1, 2, 3, 4, 5, 6, 7, 8. That's what they represent if you convert it to decimal. So as you can see, it grows in magnitude much quicker because there's a lot less room in each position to hold values. So you get all the way up to 1, 0, 0, 0, and that's 8. That's because each one of these positions is a power of 2. So the first one represents 2 to the power of 0, which is 1. The next position represents 2 to the power of 1, which is 2. And then the next position is 2 to the power of 2, which is 4. 2 to the power of 3, which is 8. And so on and so forth as you go further up the positions. In the same way, in decimal, each position represents a power of 10. So the first position here represents a 10 to the power of 0. The second position is 10 to the power of 1. 10 to the power of 2. So basically what it is that, okay, we're saying this number has 3 times 10 to the power of 0, 1 times 10 to the power of 1, 2 times 10 to the power of 2. So that's basically what binary is. It's just another way of counting numbers. So now we know how to count in binary. And with a little practice, you guys can pretty easily learn how to count in binary yourselves. But we're not just talking about binary numbers, we're talking about binary code. And the thing about binary code is that deep down, everything in the computer is stored as binary values, as binary numbers. So it's all just ones and zeros. And you're probably aware of this fact, but the fact is that you almost never see binary numbers coming up on your desktop computer because it's all hidden under layers of abstraction. And all of the calculations that are performed on these values are also done using binary arithmetic and binary circuits. And the way that it works is that it's not actually, binary numbers that are in the computer. It's just pulses of electricity that are shooting around through the circuits. So it's either high voltage or low voltage, 1 or 0. Computers use sequences of these ones and zeros to encode literally everything that you see. So as an example of a way that computers might store a piece of data in a way that is abstracted or encoded is negative numbers, because negative numbers are kind of an abstract concept. So one way that a computer will store a binary negative number is through a encoding called signed magnitude. So basically, the way that signed magnitude works is that you have a set number of binary bits that are allocated to represent the number, which means that if the computer is reading the number, it'll always look at 4 digits worth of binary code. So it will never ever consider just 3, it'll never consider 8 digits. When it's looking at a 4-bit signed magnitude number, it'll only look at 4 bits at a time. So basically the way that signed magnitude works is that the first bit is reserved for the sign, either positive or negative, and then the rest of the bits represent a standard binary number. So 0 represents positive and 1 represents negative. So we can take these two numbers for example. This would be positive 5 because the sign here is 0, which means positive, and then the last 3 bits represent 5, which is 101. And if you count in binary, you can count up to 5, and it'll be 101. Now the second number here, we have a 1 in the first bit, then that means it's a negative number, and it's also 101. So then that means that it's negative 5. Now, if you were to look at this number just as a standard unsigned binary number, you would say that number is 13. But since we're treating it as a signed magnitude number, that means that this 1 represents the sign, and then the last 3 bits represents the actual number itself. There are other ways also of encoding negative numbers, say 2's complement, but we're going to look at those in another video. But just to give you an idea of the fact that there's different ways of interpreting any binary value. If you were to say, look at this number as a 2's complement number, that would be a negative 3. But we'll look at that in another video. How about another example? Text, characters, letters, exclamation points. One way of encoding characters in a computer is by using a standard called ASCII, which stands for American Standard Code for Information Exchange. A character in ASCII is encoded in 7 binary bits. So you have 7 spaces for 1s and 0s to represent different values. So as an example, 10000001 represents a uppercase A. Another example might be a bitmap in a computer. So a bitmap is like a image, and the way that would be encoded is that it's a list of pixels, and each pixels is a 32-bit binary number, and the bits within that binary number represent the red, green, blue, and alpha values of each pixel, and then the image is able to sequence these pixels into a picture. So as a recap, binary code is numbers, which are used to encode with 1s and 0s everything that you see in a computer. Everything. Thanks for watching. Check out my next video in the series, which is going to be about floating point numbers in binary.